Have you ever looked up at the night sky and just wondered, what is all that stuff out there? And more importantly, what is the asterisk nothing asterisk between all that stuff? What exactly is space? It seems like a simple question, right? But the answer is one of the most profound and mind-bending concepts in all of science. Let's start with the basics. When we talk about space, we're usually talking about outer space. That's everything beyond Earth's atmosphere. It's the vast, seemingly empty expanse that holds the moon, the planets, our sun, billions of other stars in our galaxy, and countless other galaxies. Now, you might think of space as just emptiness, a complete void. And for a long time, that's what scientists thought too. They imagine it as a static, empty stage where the cosmic drama of planets and stars played out. But one of the biggest revolutions in physics, thanks to a guy named Albert Einstein, completely changed the picture. Einstein showed us that space isn't just an empty container. It's a thing, a physical, dynamic thing. He combined space with time to create a single, four-dimensional fabric called spacetime. Imagine a giant, stretchy trampoline. Now, if you place a bowling ball in the middle of it, what happens? It creates a dip, a curve in the fabric. That's exactly what massive objects like planets and stars do to spacetime. They warp it. And this is where it gets really cool. That curvature of spacetime is what we experience as gravity. It's not a mysterious force pulling things together, as Newton thought. It's objects following the curves in spacetime. So, the Earth isn't being pulled by the sun. Instead, the sun is so massive that it creates a huge dent in spacetime. And the Earth is simply rolling along the edge of that dent, like a marble circling the inside of a bowl. Mind-blowing, right? But is space truly empty then? Not at all. Even in the deepest, darkest voids between galaxies, it's not a perfect vacuum. It's filled with a thin soup of particles, like hydrogen and helium atoms, as well as radiation, magnetic fields, and cosmic rays. There's also stuff we can't even see, like dark matter. Scientists know it's there because they can see its gravitational effects on galaxies, but we don't know what it is. It makes up about 27% of the universe. And then there's dark energy. This is even weirder. It's a mysterious force that seems to be pushing spacetime apart, causing the universe to expand at an ever-increasing rate. It makes up a whopping 68% of the universe. So, all the stars, planets, and galaxies, everything we can see and touch only makes up about 5% of the entire universe. The rest is this dark, invisible stuff that fills space. So, space isn't empty. It's a dynamic fabric that can be bent and warped. It's filled with a tenuous mix of particles and radiation. And it's dominated by mysterious dark matter and dark energy that are shaping the ultimate fate of our universe. Let's zoom in a bit. What's the space like right here in our own solar system? It's often called interplanetary space. It's not empty either. It's filled with the solar wind, a constant stream of charged particles flowing out from the sun. This solar wind creates a huge bubble around our solar system called the heliosphere. This bubble actually protects us from a lot of harmful cosmic radiation coming from interstellar space to space. Between the stars, once you leave the heliosphere, you enter interstellar space. Here, the density of matter is even lower, but it's still not zero. You'll find clouds of gas and dust, some of which are nurseries where new stars and planets are born. Think of those beautiful pictures from the Hubble or James Webb telescopes showing vibrant nebulas. That's interstellar gas and dust being lit up by nearby stars. And if you could travel even further beyond our Milky Way galaxy, you'd enter intergalactic space. This is the closest we get to a true vacuum. The distances are almost incomprehensible. The space between galaxies is so vast the light from our nearest major galactic neighbor, Andromeda, takes 2.5 million years to reach us. And yet, even here, there are stray particles, wisps of gas, and of course, that ever-present dark matter and dark energy. One of the most fascinating aspects of space is its scale. It's almost impossible for our brains to comprehend. If the sun were the size of a grapefruit, the Earth would be a grain of sand about 50 feet away. The nearest star to us, Proxima Centauri, would be another grapefruit over 2,000 miles away. And that's just our closest neighbor. Our galaxy contains hundreds of billions of stars, and there are hundreds of billions, maybe even trillions, of other galaxies in the observable universe. All of this is happening within this incredible fabric of space-time, and it's not static. Remember, the universe is expanding. This isn't like galaxies flying away from each other through space. It's space itself that is stretching, carrying the galaxies along with it. It's like drawing dots on a balloon and then blowing it up. The dots themselves are moving across the surface, but the distance between them grows as the balloon's rubber expands. So, what is space? It's not nothing. It's the fundamental fabric of our reality. It's a four-dimensional landscape that is curved by mass, filled with energy and mysterious dark substances, and is constantly stretching and expanding. It's the ultimate arena, the setting for everything that has ever happened and ever will happen. The next time you look up at the stars, remember you're not just looking at distant points of light in an empty void. You're looking out across a dynamic, physical, and incredibly mysterious cosmic ocean. And we've only just begun to dip our toes in. Thanks so much for exploring this cosmic question with me today. If you enjoyed this journey into the nature of space, make sure to hit the like button and subscribe for more deep dives into the mysteries of our universe. See you in the next one.